YouTube is an endless buffet of videos. No matter what bizarre thing you search for, how to groom a llama, toaster unboxing, or cats reacting to cucumbers, bam! There's a video for it. But here's the catch. YouTube isn't infinite, and we're running out of space. You might assume data storage would be affordable in an age of cloud computing. After all, we can just back up our phones for a few dollars each month. But storing video data for YouTube isn't as simple as buying a billion new iPhones to act as storage space. With 82 years of content uploaded every hour, YouTube accumulates 21,600,000 gigabytes of new uploads a month, which is around 10 trillion pages of video data to its servers. Though the cloud infrastructure and content delivery networks are the core of YouTube's capacity to process this amount of data, YouTube also depends on cutting-edge algorithms for video compression and optimization. At the heart of this are sophisticated video codecs, the medium between the original video stream and the compressed formalisms that can be stored and transferred. AV1 and VP9 are two of YouTube's most essential codecs. These codecs do that by looking at the video frames and finding similarities in the subsequent few frames or within a single frame. They can then represent these similarities using mathematical models and algorithms rather than storing the raw pixel data. This allows for dramatic reductions in file size without sacrificing too much visual quality. The magic happens through encoding, where the raw video input is transformed into the compressed codec format. Encoders analyze the video, breaking it down into discrete blocks and then applying transformations to those blocks. This includes things like spatial compression, identifying areas of similar color and texture within a single frame and representing them with fewer bits; temporal compression, detecting minimal changes between consecutive frames and only storing the differences rather than the complete frame data; transform coding, converting the pixel data into a frequency domain representation, allowing high-frequency details to be selectively discarded; entropy coding, further compressing the transformed data using statistical modeling to assign shorter codes to more common patterns. The end result is a compressed video file that captures the essence of the original but with a significantly reduced file size. This is crucial for YouTube, as it allows the platform to store and transmit far more video data without overwhelming its infrastructure. But the optimization doesn't stop there. YouTube also employs data deduplication techniques, which analyze the video content across the entire platform and identify duplicate or highly similar data blocks. By storing just a single copy of this redundant information and using pointers to reference it, YouTube can achieve even greater storage efficiency. It's a delicate balance of cutting-edge compression algorithms, intelligent caching, and strategic data management, all working together to ensure that YouTube's endless video buffet can continue expanding, even as the content volume threatens to overwhelm. Understandably, the amount of videos coming onto the platform is starting to make storing these videos forever a bit of a problem, the most obvious one being cost. Storing data isn't free. Estimates suggest that keeping 1 terabyte of data in a cloud infrastructure costs between $20 and $100 per month, depending on the speed and access. Since YouTube prioritizes on-demand access for viewers, which requires a decent amount of speed, we'll use a mid-range figure, $50 per terabyte per month. If you calculate the amount of data YouTube has to handle, the cost of storing data is about $1 million a month, around $36K a day to store the 720 terabytes of videos coming onto the site every day. But it gets worse. YouTube doesn't delete content. Every month's uploads are stored indefinitely, meaning storage costs accumulate year after year. Here is a minor breakdown of the cost of hosting and streaming the videos. They use 4 different types of storage, each designed for different kinds of videos. Think of it like a massive digital library with 4 distinct sections. Let's start with standard storage, or hot data. This premium shelf space costs YouTube 2 cents per gigabyte every month. Every time you watch a viral video, a trending music clip, or the latest MrBeast upload, you're accessing content from this tier. It's expensive because these videos need to be instantly available and are being watched constantly. Streaming a 22-minute MrBeast survival video costs YouTube around 6 cents, given that the video is 3 gigabytes and you watched it in 4K. Next, we have nearline storage, or warm data. At half the price, this costs 1 cent per gigabyte. This tier holds videos that still get views, but not as frequently. These are videos you might watch once a month, like that cooking tutorial you keep returning to, or those moderately popular vlogs from last year. Moving down to cold line storage, or cold data, the price drops significantly to 0.4 cents per gigabyte. These are videos that might only get watched once every few months. Think of old tech reviews, outdated gaming videos, or content from channels that aren't active anymore. Finally, there's archive storage, the frozen data. At just 0.12 cents per gigabyte, this is YouTube's most bottomless storage vault. These videos might get watched once a year, if at all. They're the forgotten corners of YouTube. Ancient content that almost nobody watches anymore, but YouTube still keeps them available, just in case. But videos in the archive keep rising. In 5 years, YouTube will have added 1.3 billion gigabytes, or an exabyte, of new data from uploads alone. At $50 per terabyte, that's a staggering $64.8 million per year. And this figure doesn't even account for the massive archive YouTube already has amassed in its nearly 2 decades of operation, and would quickly reach the hundreds of million dollars annually, which would first bankrupt Google and then multiple countries if the issue isn't addressed quickly. YouTube's revenue model may appear sound. They make money through ads and divide the proceeds with creators, usually 55%, while keeping 45% for themselves. However, many videos uploaded onto the platform do not generate any ad revenue. Studies reveal that 70% of uploaded videos garner less than 100 views, and many generate no ad revenue. These unsold inventory videos take up space without contributing anything financially, yet YouTube still pays for these zero-view videos to stay on the site. If we estimate that a monetized video usually earns approximately $5 for every 1,000 ad views, known as CPM, or cost per 1,000 impressions, a 1 million view video would mean YouTube takes 45% of the $5,000 made on that video, $2,250, and leaves the rest to the creators. Multiply this by the around 25% of videos on YouTube that are monetized at all, and you'll quickly realize, as Google did, that ad revenue is not even close to enough to cover the costs of storing all this data. The math reveals an uncomfortable truth. YouTube's current model is unsustainable. While it's great that YouTube is an open platform for anyone to upload anything, the cost of retaining every event that ends up as a forgotten vlog, compiled tutorial draft, or niche video is becoming too high. Eventually, the platform must make tough calls about maintaining its extensive catalog. Options such as deleting old, unwatched videos, charging creators for storage, or using cold storage systems are all being discussed. None of these are great options, but you know the math. Decisions must come. Speaking of, thanks so much for all the support on the channel lately. It really means a lot, and I want to give something back to you guys. So do you need a job? That sounded a bit weird. But whether you're a UX designer, app developer, freelancer, or just a curious viewer, I want to get to know you guys, share some UX and UI tips, and maybe even get a gig. So I made a Discord channel for us and want to make this the place to be for front-end professionals. And I'm having talks with people to get some employers in there so you can connect with them too and find some jobs in the future. I'm really excited to get this thing started, so I hope you'll join me. At YouTube data scale from terabytes to exabytes, the entire platform is built and run on Google Cloud Platform, or GCP, and benefits from its sophisticated abstraction. GCP includes a wide network of hyperscale data centers, each engineered to contain high-density server racks, advanced cooling systems, and redundant power sources to provide continuous operations using software-defined networking, or SDN, and virtualization technologies. At the heart of YouTube's data storage strategy lies a tiered architecture that integrates object storage, block storage, and file storage systems to balance performance and cost efficiency. Cold storage solutions, such as nearline and cold line storage within GCP, are employed for infrequently accessed data like those videos that get no views, significantly reducing storage costs by leveraging higher latency across times. On the other hand, high-performance storage systems cater for content that is accessed frequently and is is in high demand, making sure that the streaming is done extremely fast with minimal buffering time, which is very important for an uninterrupted user experience. When a user requests that a video be played, that request is routed through one of YouTube's own content delivery networks, or CDN, an extensive, geographically distributed caching system that aims to reduce the time it takes to get that data to the user. Using edge servers located as close to end users as possible, the CDN delivers content from the closest available resource, minimizing the data distance and improving playback speed, using algorithms to identify the best edge server that should process the requested content based on up-to-the-second traffic patterns and the condition of the edge server load demanded. Technologies such as Anycast routing make this possible, directing requests by users to the closest or least congested server within the network for efficient and reliable content and service delivery. So far, YouTube has made one smart decision that is keeping them afloat in the game. They have decided on adaptive streaming. Adaptive streaming is a revolutionary technology that has transformed how video content is delivered over the internet. One of the most widely used protocols for adaptive streaming is dynamic adaptive streaming over HTTP, or DASH. This technology allows platforms like YouTube to provide a seamless viewing experience by dynamically adjusting the quality of video streams based on the user's internet connection and device capabilities. Adaptive streaming simplifies video consumption by converting it into digestible segments, often between a few seconds and a minute long. Upon uploading a video, it is compressed at various quality levels, ranging from basic 240p to sharp 4K. Every version is then sliced up, and a manifest file is created that includes the metadata about the slices, like their resolution, bitrate, and locations. The manifest file is the blueprint of this service, allowing the device watching it to discover every stream and pick which parts to ask for. The stream itself is a highly complex client-side decision-making algorithm that constantly keeps track of the viewer's bandwidth and buffer status. The server first requests low-resolution portions so that it can quickly start playing. The client checks connection stability and bandwidth consumption while the video is streaming. Under the right conditions, the stream effortlessly shuffles through high-definition sections for better viewing. However, when the network fails or is buffered, it switches to poor-quality tracks to keep the playback uninterrupted. This adaptive process works in real time, meaning the viewer can experience uninterrupted video streaming even when the internet has dropped. Adaptive streaming brings several advantages to viewers and streaming services, such as YouTube, primarily due to its intelligent distribution method. It automatically optimizes video quality depending on network conditions, which reduces buffering and delays while using fewer data points, mainly when used on mobile phones with data caps. This technology allows platforms to use up server resources more effectively by rendering multiple quality settings from a single video file. Furthermore, being device agnostic means it supports excellent quality video on all platforms, from smartphones to smart TVs, and thus is the perfect choice for today's video streaming requirements. If YouTube is facing this data problem, imagine what is going on in Google as a whole. To know more, feel free to watch our video, How Does Google Exist?